Welcome to Algebra. Slope. What is slope? Slope essentially is how a line appears on a graph. This lesson will explore this basic concept and demonstrate how to calculate slope. Slope is the steepness of a road, a ladder, a wheelchair ramp, or climbing steps, like the famous Manitou Incline in Colorado Springs, Colorado. Slope is the rate of change from low to high, or high to low. Slope is an aspect only of lines, linear functions, not of curves like quadratic or exponential functions. There are generally four types of slope. Positive, where the line goes upwards from left to right, like a truck going up a hill. It can be fairly shallow, or a bit steeper, or really steep, almost impossible to drive on, but still positive, as long as it is going uphill. It can also be negative, where the line goes downwards from left to right, again like a truck going downhill on a fairly shallow slope, or a bit steeper, or really steep, almost straight up and down, but not quite. It can be perfectly flat, horizontal, which is considered zero slope, neither uphill nor downhill, just absolutely level. Finally, it can be straight up and down, vertical, not at all possible for a truck to drive on. This is called undefined slope. Slope is often referred to as rise over run, 2/1 between the first 2 points shown in this example, or the change in y over the change in x between 2 points, 6/3 for the second pair of points in the graph. The Greek letter delta, which looks like a triangle, is used to symbolize change in science and in mathematics. Often the notation used to indicate slope is m equals delta y over delta x, with the variable m used to indicate slope. And so the slope of this line is 2, which is shown in the equation as the coefficient of the variable x in the slope-intercept form we already studied in earlier lessons. Let's find the slope of the graph shown below. First, you locate any 2 points. We've already chosen 2 in this example. Then you determine the rise. How far is it vertically from one point to the other? Well, it is 3. Next, we find the run. How far is it horizontally from one point to the other? Well, in counting this, we get 5. Slope is written as the ratio rise over run, and in this case, 3/5. The slope of this line is positive, which means it goes upwards from left to right. Now find the slope of the next graph. Pick 2 points. What is the rise? This can mean going down as well as going up. The rise in this case is going down, and so the value is -4. What is the run, which is always left to right and always positive? The run in this case is 6. What is the slope? It is -4/6. This is correct, but can it reduce? Yes, it is -2/3. This means that from any point on the line, if you go down 2 and over 3, the ending point will still be on the same line. Find the slope of this line using rise over run. Well, the slope must be 0, since the line is level, or horizontal. We learned that earlier. M equals 0. M is the letter for slope. We can prove this by using the same rise over run process. Select any 2 points on the line, find the rise, the vertical change between the 2 points. In this case, the rise is 0, because the points are on the same level. How far is the run between the 2 points? The run is 4. Slope is rise over run, and so in this case, 0/4, which is equal to 0. The slope of this line is m equals 0. Let's try this one, again using rise over run. The slope must be undefined, since the line is clearly vertical. We also learned this one earlier in the lesson. M is undefined. Again, this can be proven by using the same rise over run process. Select any 2 points on the line. Find the rise, the vertical change between the 2 points. The rise, in this case, is 6. How far is the run between the 2 points? The run is 0. There is no change. So the slope, rise over run, is 6 over 0. Well, m is undefined because you cannot have 0 as the denominator, and so the slope here is undefined. Let's practice on these 3 lines. Find the slope of the following lines. Pause the video if you need to. In this first one, we see that the rise is a -4 between these 2 points. The run is 2, which can be reduced to -2 over 1, which is simply -2. M equals -2 for this line. Try the next one. Between these 2 points, the rise is 3, the run is 3. This reduces to 1 over 1, which reduces to simply 1. The slope for this line is 1. Let's try this one. In this case, you can see that the line is vertical. You can immediately say that m, the slope, is undefined, as we learned earlier in the lesson. Here are 3 more that you should try. Pause the video if you need to. Between these 2 points, the rise is 6, the run is 8, which reduces to 3 over 4, and so the slope for this line is 3 over 4. Try the next one. Here it is -1 over 5, which is just simply -1 over 5. This last one? The rise is 3 in this graph, the run is 9, and so 3 over 9 can reduce to 1 over 3. So the slope for this line is m equals 1 over 3. Let's try one more set of examples. In this first line, the rise is -4, the run is 6. -4 over 6 reduces to -2 over 3, and so the slope for this line is -2 over 3. Try the middle line. Here, the rise is 4, the run is 1, so the slope is simply m equals 4. And this last one, the rise is -4, the run is +4, reduces to -1 over 1, the slope is m equals -1.